This video is focusing on slope-intercept form. We'll learn how to identify the slope in the y-intercept when the line is written in slope-intercept form, how to graph lines in slope-intercept form, and how to calculate the slope from 2 points. So the first thing we need to do is to figure out what is slope-intercept form. Slope-intercept form is a specific equation of a line that's written in this format. Y equals mx plus b. First, let's look at this mx here. This m and this x are multiplied together. Even though we don't have a multiplication dot or we don't put parentheses, we know that these two are going to be multiplied together. This m here represents the slope. We can also describe the slope as the rate of change. This here, this b, represents the y-intercept. The y-intercept will be positive when this sign here is a plus sign, and it will be negative when this sign is a minus sign. This x and this y here represent the x and y coordinates of points that exist on this line. So when we're writing out the slope-intercept form of a line, we're going to replace this m, this slope, with some number, and we'll replace this b, or the y-intercept, with some number. But we leave the x and the y here as variables. We leave them as is. Now let's use this general equation we have for the slope-intercept form of a line to identify what the slope and the y-intercept are of each of these lines below. If we know that the slope-intercept form of a line looks like this, then when we look at this equation here, what is the slope and what is the y-intercept? You should have said that the slope here is 5. The slope is 5 because we know that the slope is going to be the number that is multiplied by x. The slope does not include x. The answer is not 5x, it's just 5. The y-intercept here is 2. It's a positive 2. So this equation here is the slope-intercept form of a line that has a slope of 5 and a y-intercept of 2. Let's try the second problem. What is the slope of this line and what is the y-intercept? The slope of this line is a negative 3. Negative 3 is being multiplied by x, so we know that that is our slope. Our y-intercept here is 9, or a positive 9. So this is the equation of a line that has a slope of negative 3 and a y-intercept of 9. Now figure out what is the slope and the y-intercept of line 3. The slope of this line is 1/2. You'll see later that when we're graphing, it's actually really helpful for us to write numbers in fraction form. Usually, if our slope is a number that isn't an integer, I like to write it as a fraction because it helps me graph instead of using a decimal. The y-intercept is going to be a negative 17. So this here is the equation of a line that has a slope of 1/2 and a y-intercept of negative 17. What is the slope and the y-intercept of line number 4? The slope is negative 5/2. We could convert this to a decimal or to a mixed number, but when we're graphing, it's actually easier to leave this as an improper fraction. So as long as this fraction is the most reduced it can be, we can just leave it in this form. The y-intercept would be 1/2. And it's okay for us to get fractions for the y-intercept as well. So this would be the equation of a line that has a slope of negative 5/2 and a y-intercept of 1/2. The next thing we're going to learn is how to graph lines in slope-intercept form. When we want to graph lines in slope-intercept form, the first thing you have to do is plot the y-intercept. By definition, the y-intercept is the y value of the point that exists on our line where it crosses the y-axis. So the y-axis is this vertical one, the one that's up and down right here. So let's say our line looks something like this. Then this value here, the y value at that point, would be our y-intercept. If our line looked like this, then this would be our y-intercept. You get the idea. We could have a positive or a negative y-intercept. What will determine that is what this sign is here. If this is a plus sign, then we'll have a positive y-intercept. A positive y-intercept will be located anywhere above the x-axis, so that's any of these y values here. If it were a negative y-intercept, then that means that this sign here would be a minus sign. And negative y-intercepts exist anywhere below the x-axis, so that's any of these values here. So as we said, our first step is to plot the y-intercept. So now we have 1 point on our line. To create the rest of the line, we have to use the slope. So the slope, as you recall, is going to be the number that is multiplied by x. This number will tell us how many spaces we have to move either up or down and to the right to figure out what the next point is on our line. So when we talk about slope, we can describe it as just how steep a line is. We've also previously described it as the rise over the run. So when we say rise, we think about how do the points change vertically, or how do their y-coordinates change? When we talk about the run, we mean how do they change horizontally? How far do we have to move it to the left or to the right? And that is what the change in the x-coordinates are. So if we have something that has a positive slope, that means we're going to move up some amount and to the right some amount to get to our next point. Because it has a positive slope, if we go from one point to the next point and we have to move up some amount and to the right some amount, we'll end up getting a line that looks like this, that will be going up from left to right. So if we had a line with a negative slope, that would look something like this. We'll start at our point, and then we go down some amount and to the right some amount, and then we'll end up with a line looking like that, that's going down from left to right. If we have a number that isn't written in a fraction form where we can clearly see how many spaces we move up or down and how many spaces we move to the right, we can just rewrite it as a fraction by putting whatever the slope is over 1. That would just tell us we'd have to move to the right one space whenever we're plotting our next point. So now let's look at some examples of this. The last topic we're going to cover in this video is how to calculate the slope from 2 points. So in order to figure out the slope from 2 points, we're going to build on the idea that the slope is really just the change in y over the change in x. Let's look at this line, for example. For this line, I know that my y-intercept is 3 because this is the y value of the point on the y-axis that exists on my line. Then from here, I had to move up 1, 2, 3, 4 spaces. That is my change in y. I moved up 4 spaces, and then to the right 1 space to get to my next point. So my slope would be 4 over 1, which is just equal to 4. So if I were given the coordinates of these 2 points, without having to graph it, I could figure out that the slope is 4 just by using subtraction. So let's first come up with the coordinates of these 2 points. Now that I have my 2 points, I can use the slope formula and subtract the values to figure out what my change in y is. So looking at this, I'm going to start with the y-coordinate of one of my points. It doesn't matter which point I start off with, but let's just say I use this green point. The y-coordinate of this green point is going to be 7. The y-coordinate is always the second number in the pair of coordinates, or you can look along the y-axis and figure out what that value would be. So I'm going to start off with the y-coordinate of the first point. Then, because I used this point first, this one by default has to be my second point. I'm going to figure out the difference between this point and this point vertically. We already know that the difference is 4, right? We went up 4, so the difference should be 4 here. When I subtract them, minus 3, I, in fact, will end up getting 4 at the top. On the bottom, I have to figure out what is the change in x. So to find the change in x, I'm going to set it up the same way. Because I started with the green point, and this is the y-coordinate of the green point, I have to put the x-coordinate of the green point on the bottom too. So I'm going to start with 1 minus, and then the x-coordinate of the pink point is 0. So my final answer is I'm figuring out the change in y, the change in these y values, is going to be 4. And the change in these x values is going to be 1. Therefore, my slope is just 4. So this answer matches up with this one. It's the same answer because it's the same line, so we should have the same slope. This here is just another way for us to figure out what the slope is using subtraction without having to actually graph the line.